hopped into the class. I'm like, I guess I can let him in. All right, so today is it. We're done. The last day. Sometimes it's like the interactions, because you don't hear anything else.
I was sitting like that. I was watching you live.
Yeah.
I can't hear what they're saying.
Right.
So then I'm like,
yeah, you missed the interaction.
You stop speaking. Your mic doesn't pick up that.
Yeah.
And then you answer a question. I don't know what it was.
I had I used to have a room mic that could actually pick up everything, but it picked up everything. And it was yeah, including a little side conversation. It was like it was way too distracting. So all right, yeah. Okay. So I'm not doing anything really new today. Actually, all we're going to be doing is looking at hypothesis testing. The only thing I'm adding in is 11.4 is the hypothesis testing for proportions. So, but the actual hypothesis testing process is exactly the same. It's just how we find the z-score changes a little bit. But we've actually already done that when we did critical, the confidence intervals anyway. So that stuff all stays the exact same. Yes?
Why did they change the steps in finding the z-score? The ultimate goal was to find.
So it's because of how you have to find it. So proportions, remember, with proportions, you don't have a standard deviation and a mean and stuff. You have a percentage of that. So it's a binomial thing. So because we don't have mean and standard deviation, we have to find those differently. That's why your z-score changes for proportions. All right, so let's look at this one. The nutrition label for Oriental spice sauce states that one package of sauce has 1,190 milligrams of sodium. To determine if the label is accurate, the FDA randomly selects 200 packages of Oriental spice sauce and determines the sodium content. The sample has an average of 1,167.34 milligrams of sodium per package, with a sample standard deviation of 252.94 milligrams. So, we want to do our hypothesis testing. So we have to ask ourselves those wonderful little questions. Well, actually, let's find our hypothesis first. What's our null hypothesis for this?
The mean is equal to 1,190.
Right. So that's the null hypothesis. What's the alternate hypothesis?
Mean is equal to.
Yeah, because it says we're trying to determine if the label is accurate, correct? So low or high, it still would not be accurate. So yes, we're going to do not equal to in this case. All right, so this is a two-tail test. So we got that. It doesn't give me my confidence interval, or not confidence interval, significance level. So in a lot of situations, now in Hawks, they're going to have to give it to you because they want a specific answer. But most situations in life, you're not going to necessarily have that. You're going to find one. So we have a 0.01, 0.05, and 0.10 significance level. Which one do you think the FDA, now remember, the smaller the significance level, the more accurate you want, right? That's the better, the smaller the number, the better the stats is going to be. Which one of those three do you think the FDA would want to use? 0.01, 0.05, or 0.10? So they probably want it pretty accurate, right? They're going to want those labels to be pretty accurate. So they're probably going to use 0.01. So let's use 0.01. Okay. Normally, in your real life situations, 0.05 is typically used. In your medical or those type of things, 0.01 or even better than that actually can be used. The FDA, this is something that can be harmful to people. If there's too much sodium in it, they'd probably want to be pretty accurate with that number, although 1,190 is pretty high to begin with. 0.01 is what we're going to look at. All right. Next question. we'll assume that it's random. We'll assume that we can do this. Otherwise, I wouldn't be asking it to. Are we using the t-score or the z-score? So do we have these population standard deviation or not? Do we have the population standard deviation? No, we have the sample standard deviation. So we have to use the t. Okay, so we're using the t-score for that. All right, so t. So what is the mean that we got from my sample? What's the sample mean?
1167. I don't know where they're like.
That's okay. 1167.34
Started saying it, that's why I didn't
Yeah.
say it, 'cause I was like,
minus the 1190. It's okay. I knew the number you were talking about. Then we divide by the sample standard deviation, which is what? 252.94. And we divide by the sample size, which is what? 200. Okay. I actually got rid of all those. I cleaned up my bag, so I have to look this up on the
This is a totally unrelated question, but when's our test?
Thursday. And it's online. Yeah. All right. You didn't pay attention on Tuesday, did you? Or you didn't watch the video to catch up what I said? Yes, the test is next Thursday and it's online. So we will not have class. It'll be online on Hawks. You have to take it there. All right. So let's look at what's that, or come up with that calculation. That's the first thing I got to do. Sorry, totally tossed me off. So we've got. All right, so we get negative 1.27. All right. So let's look at our t-table. And we're looking at our two tails for 0.01. Okay, so look at the top. One tail or two tail. We're looking at two tails, so we're right here.
that's not a range.
No. No, because that's one tail's the one on top, two tails is the one on the bottom.
Oh, okay, that's
Yeah, see it says one tail and two tails right inside there. So you're right. And this one, my degrees of freedom is going to be 199, which isn't on the list. So remember I said basically anything over 30, you can really just use the bottom number because that's basically going to go to Z anyway. So you can use that 2.326. If there's one close to it, you can use that one, but it's pretty darn close to 2.326 anyway. So 2.326 is my T that I'm going to compare it to.
Wait, why are we using that?
Once you get down that far,
Right, Lawyer Grace, because the two tail, why do we get the 0.0?
oh, shoot, I went to the wrong one. Sorry, 2.576. I was looking at the wrong one when I went down the list.
Okay, and that's because for the, we got 0.01.
Yes, yes.
Okay.
So 2.57. Sorry, 2.571. I looked when I scrolled down my list. I looked.
So why are we using, is the negative 1.27 the, like, how do I word this? I know what I see it in my head, but when you draw the bell curve, is
Yes.
that the two numbers at the bottom that make it either like fail to reject or reject?
No, you got them backwards. The negative 2.57 was 576. Yeah. and 2.576. That. So reject. And fail to reject. Okay, so the Z or the t-score that we get when we look at our table, that's where my boundaries are. Okay. The t-score that we got when we did the calculation is what my problem is stating. So in this case, my problem stated it was negative 1.27, right? So negative 1.27 is here. And that is in my fail to reject column. In this case, it's the not equal to. Is two tails. Because you can look at both sides. Well, either side would be bad. If it was greater than or less than, that would be one tailed. Because we'd only be looking in one direction.
So anything else than that.
You really only have three options: not equal to, greater than, or less than. So in this case, it is in the fail to reject column. So based on the data that we have, the FDA would determine that they will fail to reject the concept that the sodium is different than it's labeled.
Why is it not
Because that would be one tail if you look at the T table.
Oh,
Okay, wait. Could you explain why it's failed to reject again? Because it did not put.
So my rejection region is from negative 2.576 to 2.576. Outside of that.
Okay, my brain was putting the negative 1.27 as the two numbers.
Right. No, that's what I'm saying. The number that you picked on the table, that's your endpoints. That's the boundaries. The number that you got is the number you're testing. So you have to find out where that fell on the bell curve. And it happens to be the first one that we've done in class that failed to reject. I picked them today that had a variation. So, okay. So in this case, the FDA is going to assume that the number that's on the label is correct because their data didn't show that it was significantly different. Okay. The other way to look at this is we can find our confidence interval, which we did before and which is on your test. So it's a good time to review that anyway. So remember, these numbers down here can be directly translated into a confidence interval that we know it's somewhere between those values. Okay. Anybody remember how to do that? Yeah.
Take the percentage dividing, no, minus A, right?
Yeah, but we don't have to do that because we actually already got those. We're a step past that
Oh, okay.
because we already got this. Take this number, multiply it by the standard deviation, and add and subtract from the 1190. Okay. So you're going to take that number, multiply it by the standard deviation, and add and subtract from the 1190. So in this case, what was my standard deviation? 252.94. So times 2.576 plus 1190. So that's order here. 1841. Oh, hold on. I forgot to divide by the 200.
write that out.
Yeah, I'm going to. I want to get the actual, I forgot to divide the standard deviation by the square root of 200. There, that's better. I'm going to write it down 1 second. I just want to get the numbers. And then I will, actually, you know what? I'll just do it this way. Because this is exactly how I showed you before. So this, remember doing this, we did the 1190 plus that times z-score, and then 1190 minus that. That's your confidence interval. So that right there is how we would get my confidence interval. Confidence interval? Yeah, I was going to the test. Because that was chapter 9, I think. That's why I said it was a good time to review that.
I think for it being like one, like that, it'd be plus or minus some sort of z-score.
Times the standard deviation. Yeah, that's what I just said. That's the standard deviation.
Oh.
Yeah, I just put that in. So the other way to look at fail to reject, oh, well, sorry, I'll go back. The other way to look, I can talk at the same time. The other way to look at failure to reject and reject is the number that I got in between those two values there. So the number they gave me was 1169, right? Is that in my confidence interval? Is that within those values? It is. So it's within those values. So that's within my confidence interval of what I would think should happen anyway. Because remember, that was the whole concept. Is like once we found those two numbers, I would expect this to happen, and it should be between these two values. Well, 1169 falls in there, so I'm confident that that would make sense. If it fell outside of that, that's when we start to say, well, that's unusual and something's wrong. That's when we would reject. Okay, because if my assumptions are incorrect, then I'm going to get data that's outside, and that's what I'm saying. Something is wrong with this mean, so maybe we should look at that a little bit more because it's outside of my confidence interval. Okay. All right. Researchers are studying the effects of diet on growth. They want to know if vegetarian diet affects the height of a child. So 12 vegetarian children that were 6 years old, they selected the average height of the children is average height of a child or children is 42.5 inches. The average height for all 6 year-old children, hold on. The average height of the children that they studied was 42.5. The average height of all 6-year-old children is 45.75 inches with a standard deviation of 3.8 inches. Okay. So figure out if you're going to reject that null hypothesis or accept or fail to reject the null hypothesis.
Is it normally distributed?
Yes, we'll assume this is normally distributed, otherwise we can't do any of this. So we're gonna, you can make the assumption that if we're giving you the problem, you're gonna be able to do the test that we got. Because if it's not normally distributed, you'll have to use those other tests that you're gonna learn in Stats 2 if you take Stats 2. I think Stats 2 is using the exact same book and stuff, so you'll end up just using the second half of it, really. You actually will probably start in chapter 11. You'll do 11, 12, 13.
That too.
Yeah, 14. I'm going to slowly do it while you're working on it. So
Are we assuming for assuming 0.01 or set average?
this is medical, so 0.01, yeah. anything to do with medical, health, food, like safety things, you want to be a little bit more picky.
The 11th one today. No, that's like the 13th one. I've done 13 scam calls in one day.
Wow.
It's one.
Jeez.
No, like, this one she has, and so
Your phone number got on some kind of list.
Because the problem is they started wanting me to get some zero numbers, and sometimes my doctor's office.
Yeah, so you-
needs
yeah.
zero numbers, or sometimes my doctor's office comes up with scam lately. And I knew I was gonna get a call from my doctor's office today, so I had to answer that. I started answering.
What do you got, an
"Yes,
iPhone?
Anymore, you stop and stop. How can I help you today?
You got an iPhone?
Yeah.
Android's got a nice little feature on it. At least the Pixels do for screen calling. Literally comes up, I hit screen call, and it says, "This is your Google Assistant answering the phone call for. Can you please give a brief description of what your call's about?" So if it's the doctor's office, they'll say that, and you just hit answer call. If not, you just hit end call. Makes life nice and easy. All right, so this is what we got. Oh, sorry. I can't take credit.
That was so sarcastic.
Sorry.
Sorry.
Where'd you get to?
I am just putting it in Facebook.
Oh, okay.
And I still haven't done the developers or anything.
Gotcha. Couple quick things when you're looking at it, you have to figure out and decide. The null hypothesis should have been equals 45.75 because that's the average height. And since it says they would like to know if it affects the height of the child, they're not saying less or greater than or less than, so it's not equal to. Since this is a medical thing and they didn't talk about it, use the 0.01 significance level.
We're not using the T-scores, so how do you find the two numbers? Or are we using the T-scores?
No, you're using Z. You're using Z for this one because we have the standard deviation of the population.
N is same to me, right?
Huh?
N.
No, N is the number of how many you have. So 12 in this case, yes. Yeah. Yeah. So we're going to use Z-score because we have the population standard deviation, not the sample standard deviation.
I know. I know, like,
The critical the confidence interval? Oh, yeah. So okay, I know what you're talking about. So we'll do our formula. We got negative 2.96 should have been the number you got for the z-score for the problem. Now we want to look for our z-score for our significance level. So it's 0.01. So we go back to, remember I said the z-scores are on the t-table, so we can look at that same thing. It's two tails, so 0.01. And we just go all the way to the bottom, and it's 2.576. Okay?
Drew, say that again. Hold on. Sorry.
Your t-table has the z-scores at the bottom.
Yeah.
So we look for our significance level, which is 0.01. And then we just go to the very bottom, and that's my z-score. So 2.576. So 2.576 is my z-score there. The number that I have is outside of the positive to negative 2.576 because it's at negative 2.96. So we are rejecting the null hypothesis. No, I'm not going to do the confidence interval for this one.
Okay, what number did you get? 'Cause I
Which
got
one?
different numbers. Because I got for the 42.5 minus that number, I got negative 0.3.
Negative 2.9627. Da, 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 da.
Yeah.
That's what you should get. I'm wondering if you typed the number in wrong or.
Oh, yeah.
Okay.
2.38.
That would make a difference.
And like some-
So in this case, the researcher could statistically say that a vegan diet has an impact on the height of a child. So, actually, let me rephrase this. It says a vegetarian diet, which is different than a vegan diet. So, because if it's a vegan diet, they're not even giving it milk, which would definitely affect the child. But vegetarians can eat eggs and drink milk. So, but in this case, that's what they've shown. Okay. Are we starting to get the fail to reject and reject a little bit better?
Yes.
No, you're still not. Yes. Okay.
Okay, I'm understanding where the numbers are coming from.
So in this case, if we look at the visualization is always good. So if we have our
Okay. So the number that we got, the 2.576, that's plus or minus.
yes,
Yeah, okay, and then because the number.
And then the number I got here is-
Okay, yep.
now we're in my reject.
If I put plus or minus next to the 2.576, it makes sense.
Okay.
In my head, I have to right.
Yeah. Now that actually comes up when we're looking at the two-tailed tests. You have to have the plus or minus. If we're just looking at one-tailed, we would just look at the one side of it, whichever side we're looking at. If it's less than, it'd be the negative side. If it's greater than, it'd be the positive side. So, all right. Okay. Let's just look at the formulas for proportion. You already have these formulas. These are the same formulas we used when we did confidence intervals. They're exactly the same. So the one thing that we do have to kind of test, and again, most times it's going to work out, is you have to do your n times p and make sure that's greater than 10. And then your n times 1 minus p and make sure that's greater than or equal to 10. So you do have to do both of those, just a quick check. But your standard deviation formula is the same, and your z-score formula is the same. So, and in this situation, you're always using z because we can find the standard deviation of the population, basically. Okay. All right. We good with that before I switch over? Okay. Because now we're going to use it. A socially conscious corporation doesn't exist. Wants to relocate their headquarters to another part of town. One concern expressed by workers is that their commuting distance will increase. The corporation has decided that if more than 50% of its employees will have to drive farther to the proposed new location, they will cancel the move. In a random sample of 398 employees, 201 indicated that their commuting distance to the new office will be longer. Based on the sample data, should the corporation cancel the move? I guess it depends on how many people they have. But yes. And actually, depending on, they say indicated, they could have easily just taken the employees and actually looked at their addresses and calculated it that way too. So you might not want to do everybody, but 398 is a lot of employees that they did. All right, so let's look at, first off, let's look at our thing to make sure, or let's get our null hypothesis and our alternate hypothesis. Let's do that always first. Keep forgetting to do that first. What's my null hypothesis? No, it's 50. So in this case, when you're looking at it, this is new because we haven't done this yet. Because typically it's the mean they're going to give it to you. In this case, it's what we're looking at in terms of the proportion. So in this case, the proportion is 50%. And my alternate hypothesis is that if a P is greater than 50%, I'm going to cancel the move. Okay. Yeah. Yeah. So in this one, it's because it's more than. That's why it's greater than. And the last ones we were doing, it was differed or things like that. So it was not equal to. So you have to look at what they're looking at. In this case, they're looking at greater than 50%. They're going to cancel the move. So we're going to look at greater than 50%.
Specific, and then you have to like really pay attention to what symbol you're using.
Yes. So in these, I think these are actually P hats. So. All right. So let's look at our problem. So the first equation I need to do is I need to find my test conditions. I'm going to tell you right now they work. So we're going to just assume that. I'm not going to do it out. I don't believe Hawks makes you do that, the assumption steps anyway. So let's look at, we need to find our P hat and then our standard deviation. It's proportion of the sample. It's a P with a little hat. P hat. That's I don't know what the other way to say it. It's like a P with a little hat.
Proportion of the standard deviation.
Yeah. So we have to do our proportion of the problem of what they gave me, the sample data, and then we have to find our standard deviation. Do those two things. So out of my 398 employees, 201 that they would have to have a greater commute. So it's 201 divided by 398. What is it?
505.
Okay. All right. So now we can do our Z test. So Z is 0.0 or 505 minus 0.50 divided by the square root of P times 1 minus P divided by 398. And what do we get? Yep. All right. So now we can go to our, we'll use the T table. We're using the Z, but we're going to do it on the T table because it's very nice to use for this stuff. And it has all the information that we're going to need on it. So is this one-tailed or two-tailed? It's one-tailed because it's greater than. So we're just looking at the one side on this one. So this is one-tailed. So we're looking at one-tailed for 0.01. And then we go straight down that row, and it's 2.326. Yeah. Okay. So now when we look at this one, when we look at the bell curve for this one. So 2.326 is over here. That's my only reject region. I don't have one on the other side. So, and the number I got was 0.199. So it's in there. So we're failing to reject. Okay. So they'll be moving. And actually, in this case, no matter what level of significance they used, they still be moving. Even if 0.1 was too significant of a level for this situation, I probably would have used 0.10. It still would have caused them to move. Because even if we did at the 0.10 level for one-tailed, that's still 1.282. So they're still moving. So you would fail to reject that the number of workers that would have to drive farther is more than 50%.
Why'd you do 201 over 398?
What?
Why'd you do 201 over 398?
It's to figure out the percentage, the proportion of what they sampled. They had 201 employees out of the 390 employees said they would have to increase their commuting distance. So you can see, like, except for basically this little thing right here, everything else is exactly the same. Nothing changes in the process. Okay. All right. Try this one. I'll give you a little more time on this one.
I was with that. I was very sad.
You do.
You know, like you dish it back, like extra paper.
Any of it that I got?
No, not, they're not even sending on iPads. How about? Speak about that.
Oh.
I was like, what?
It's literally an hour long. Literally an hour long. I will tell you, my high school class could figure out which ones I liked because I would joke around. If the class annoyed me, I just wanted to get through the class, so I didn't really. Pretty much. Oh, we always pick favorites. We always pick favorites. Yep, didn't get rid of me. Yeah. Oh my god. Yeah, you'll know real quick when people don't like their strip. Yeah, that's what it is. Yeah, yeah, yeah. The null hypothesis is P equals 150. The alternate hypothesis is I think it was pretty easy. I don't know. You guys got the practice test. Well, like, I actually don't remember how many things we looked for as compared to 11, 2, and 11, 3. So. If somebody had 500 over 931 done, so I don't have to do it. Anyway, yeah, that's 530. Okay, good.
Nice.
Yeah, that's the percentage. That's the problem. That's the sample one they got because they did 500. It's always so. It's what they did. Their sample, their project. So in this case, it says research this 931 windows were picked. 500 of those windows were still leak free. Uh huh. Oh yeah. Oh yeah. 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 These are not ones that you can just go. Oh yeah, just pick some numbers out, throw them in a formula. Not these type of problems. Yeah. Not these type of problems. Huh? So it's if you look at the problem, notice nowhere in this problem does it say average. So, so like this one, if we look back at the first ones, it says the average height. That's why we're using mean and we're doing the mean stuff. In this one, or like in this one, we're looking at a proportion. It's 50%. And this one, it's 50%. So that's how you can tell it's a proportion, not a mean. Yeah. Mm-hmm. Because it's not a health or safety issue. So they didn't give it. Sometimes they'll give it to you. This one they didn't. Yeah. if it's a medical or a safety. If you really don't care that. It is.
Is.
Yeah. Yeah. Yes. Yeah. Yeah, that's the exact. Yeah, I just typed it all. Yeah, that's N. P, 1 minus P. And that's P hat minus P. It gives you a percentage. Oh, sorry. I can go the other way. There you go. It gives you a percentage. The other ones will give you a mean or an average. Yeah. And the other thing is they won't give you a standard deviation anywhere in this process because you have to find your standard deviation. All right, so yeah, it's typically used for medical and safety type issue. Yeah, 0.01 is typically medical and safety. 0.05 is the one that most situations use. Rarely do you use a 0.1 or 0.2. Those are the situations where you really just don't care that much, or you don't need to be that confident. So 99% of the things will use 0.05 or 0.0. Yes, I'm not done yet with this. I did not actually clean up my bag because I had a test for the class today. I have no more tea tables. All right, this one comes out to be 2.26. All right, so now if we look at our tea table, and we're doing, it's a one-tailed. So it's a one-tailed at 0.05. So it's 1.645. Okay, so it's one-tailed, so it's 1.645. So in this case, I'm rejecting. Okay, because the Z I got is bigger than the Z that was on the table. Yes, if you go all the way to the very bottom, it's 1.645. So in this case, I'm rejecting. Okay. All right. All right, this will be our last one. I should switch back over. Huh? Oh, sorry. I reject. Yeah. I wrote it and I was on the T table. Yeah. 2.267, 2.26. The number we found is bigger than you see that was on the table. All right, last one. Anybody ever work? Anybody like working on like those type of fields and stuff like that? I think most of you guys are like helping. Pretty much any auto shop you go to, or actually most manufacturing shop places you go to, they have a specific amount of time a job should take. So if you go into conference hire or anything else like that, get your brakes done, it should take 2 hours. You're getting charged for 2 hours. If they get it done in 45 minutes, you get charged for 2 hours. Okay, that's how they do their value. That's how they set their pricing. And pretty much any service, like if you call up an electrician and say they want you to put in a new electrical socket, they have an amount of time to take. That's what they're charging for. If it takes less than that. That's the goal. You want to take less than that to make more money. So this company is now trying to set that in for a union contract. So but most of those are small businesses that do it. Okay, figure out this problem for me. The surveys, the student evaluations are up online. So if you go in your comment for your classes, I do actually read your comments. So if you have comments, put them in. I've actually changed things I've done classes based on the comments and feedback. So both good and bad. Yeah, I think actually it's probably in your comment. I don't think it's in mine. Okay, it's in your email. Like, I don't know where you guys get it. I just know it's. Yes. No. You're evaluating me. Yeah, I evaluate you on your grades. That's okay. That'd be different. Try that with that. Yeah. Is this the proportion? Is there a percent anywhere in this problem? Very good. Why is the last problem? Because one of the questions that you guys asked was, how do you know which one to do? So, right. So you have to be able to read the problem and figure this out. Like that's something that you have to be able to do.
From them.
Yes. The steps don't change except for the very bottom of the form. Because you use the P. That's the only change. Yeah. So, right, I was gonna say, so on your card or something like that, right, give or mean this proportion this. So you can if you can choose, then you can just look at your index card for your farm. Okay? That's because all the steps are basically exactly the same. Finding your Z and everything else like that. Yeah. Just draw your thing out. Oh, yep, it's there. We're good. What's the answer?
Oh, yeah.
Couldn't you tell just by looking at it? What's my null hypothesis? And that means it's 45. My alternate hypothesis, the workers are saying it's greater than 45. Actually, they're just contradicting. So it's not equal to 45. Although they do much, they're probably really trying to say it's bigger than that. But in this case, the way it's written, to contradict the first one through the guide, it's not equal. Because technically he'd be wrong either direction. All right, so we're doing at a 0.5 significance level. So why are we doing a T? You picked it. Why? Is she right? Huh? Right. The standard deviation they gave me is of the standard. We don't have the population. You're right. I never said you were wrong. I asked you why. Yeah. It's the pieces for the formula. So this is T because they don't have the standard deviation of the population. T. So we're going to do 47 minus 5 over 10 divided by the square root of that. Correct. We have the standard deviation of the sample, not the population. Although in this case, with 125, it doesn't make much difference. And the formula for T and Z are exactly the same. This formula right here is exactly the same for T and Z. That doesn't change at all. The only difference is when you look at your table where you're getting your number. And actually, like I said, for 125, it's not going to make that big difference. We're using 0.05. And 2 tails. Yes. So 1.9, and I said if it's over 30, you can use Z, so 1.9. So in this case, are we rejecting or failing to reject? Huh? The number that I have here is bigger than that, so I reject. All right. So the employees have determined that the job probably takes not 45 minutes. Based on the numbers they have there, it's probably a little more than 45 minutes. However, while it's statistically significant, does it really truly matter? If the supervisor goes, okay, it's 47 minutes instead of 42. In the grand scheme of a contract and negotiations, does that 2 minutes make that big of a difference? No. So it's probably, even though it's significant, statistically significant based on what you did, probably not worth fighting for those. Okay. That's actually where chapter 11.6, that was the only thing in chapter 11.6. Is that there are situations where we could do the statistics, do everything else, and it's significant. But in reality, it doesn't make that big of a difference. So it's not worth having that fight over. So, and that's where that problem is. There's another one that they said was like 2,000 bags of dog food. It was 0.01 pounds off, which was significant, but do you really care if your dog food bag had 0.01 pounds of dog food less in it? No, it's one kernel of dog food. Like, you're not going to notice the difference. So while statistically significant, practically different. Okay. All right. So Tuesday is the review for your test. I'm going to do exactly what I've been doing all along. I'm going over the problems in Hawks on the review test. The test is next Thursday. It is online and